The molar mass of NaOH is 40.0 grams of NaOH in 1 mole of NaOH. And then I'm given this enthalpy, which tells me that 1 mole of NaOH will release 44.51 kilojoules, which tells me that Q of the system is minus 55.6 kilojoules. So now I can move to Q of the surroundings. Q of the surroundings is going to be equal to the mass of the surroundings, which we're going to have to give ourselves a minute. Our mass of our surroundings is going to be 1 liter of water in 1 liter, there's 1,000 milliliters. And then in 1 milliliter, we have 1 gram of solution. And so this gives me 1,000 grams of surroundings. So I have 1,000 grams. My specific heat of water is 4.184 joules per gram degrees Celsius. And I'm looking for my final temperature. And my initial temperature is 20.0 degrees Celsius. Now, right now, as I'm looking at this, I have 2 unknowns, Q of the surroundings and TF. So this is where I need to use my first law of thermodynamics to help me out. And so I know that Q of the surroundings is equal to minus Q of the system. And so Q of the surroundings is equal to 55.6 kilojoules. Now, I'm looking ahead. We're going to run into a problem because in my heat capacity, I have joules, and here I have kilojoules. That's going to give me a problem. So I am going to look ahead, and I am going to convert to joules. Okay? So now I know that Q of the surroundings is 5.56 times 10 to the 4th joules is equal to 1,000 grams times 4.184 joules per gram degrees Celsius times the final temperature minus 20.0 degrees Celsius. And if I do my algebra, I find that the final temperature is going to be 33.3 degrees Celsius. Now, I'm not quite done because, well, I have an answer, but the next step is to sanity check this answer. So if I look back here, I have a negative sign on this delta H, which means that this is exothermic. So that tells me that my final temperature should be bigger than 20. And if I look back at my answer, that is what I get. And so therefore, I'm pretty confident that I have done my algebra correctly. Okay, so in the next video, I'm going to do another example Very similar to this one, but going at it from from a different direction and solving for a different piece. So if you're still struggling with these questions, stay tuned and there will be another video.